desert landscape. Actually, it's just a few weeks old. But some of the oldest land on Earth came from the same place this did. From volcanoes!
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill. Volcanoes! Science rules.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by the law offices of Magma, Lava, Tephra, and Pumice, making mountains out of ventals for over 4 billion years.
Take a look at this. It's a mountain. Well, actually, it's a volcano. Volcanoes are formed when hot, molten rock from deep inside the Earth finds its way to the surface. Now, this isn't hot, molten rock. It's a mild acid. And to help it find its way to the surface, we'll add some sodium bicarbonate. This will be like hard rock.
Right.
Above the molten rock from deep inside of the Earth.
Mm-hmm.
See, the pressure builds up and it builds up. And eventually a volcano will erupt. It'll blow its top. It'll
Right.
explode.
When?
Anytime now. There it goes. You're saying, Bill, you know, I've made volcanoes like that in my kitchen. Maybe better. I mean, that's it? That's it? I mean, what's the big deal? What's the big deal? Take a look. Volcanoes can blow down entire forests in just a few seconds. They can reroute rivers and form new lakes, carve new valleys, transform entire landscapes in a matter of hours. And that's what happened around here, when that mountain right there blew its top. It's Mount St. Helens, and it erupted in 1980. It's in the Pacific Northwest of North America. Now, there are different types of volcanoes. They don't always explode when they erupt. Some volcanoes ooze. Now, when I say ooze, I'm talking about hundreds of thousands of tons of rock. At well over 1,000 degrees Celsius, they come out of the earth and they cool off to make new land. Land that you and I live on. See, there are different types of volcanoes, but they all do the same thing. They all build up the Earth's surface.
Since the Earth was young, volcanoes have hurled fiery rock from the planet's interior to its surface.
Volcanoes usually occur where two tectonic plates run into each other. Like here's Mount St. Helens, where the Pacific plate is colliding with the North American plate. But the Hawaiian Islands are right here, in the middle of the Pacific plate, with no other plates around. And the Hawaiian Islands are made of volcanoes. So how did they get there? Take a look at this. It's our drifting plate magma plume simulator of science. This is the Pacific Ocean. This is the Pacific Ocean floor, the Pacific plate. And this is a boat. As near as we can tell, deep beneath the Pacific plate, there's a stream of extremely hot magma, what we call a magma plume. See, the magma in the plume doesn't flow continuously. Instead, it sputters like smoke from a chimney. And it's always in the same spot. So the pressure in the plume builds for it to punch through the Pacific plate.
Please.
This. And then the plate moves. The pressure builds, and the plume punches through again. The plate moves some more. And the plume punches through.
Volcanic rock and ash, accompanied by billowing clouds of steam, shoot into the air and build a new island.
So this is how the Hawaiian Islands were formed. We figured it out when we noticed that the rocks on the northern islands are older than the rocks on the southern islands. Because the Pacific plate is drifting this way. We can detect it. So, the pressure in the plume built up and boom, an island is formed. Pressure built up and boom, an island is formed. Or boom, an island is formed.
Volcanoes erupt because there are gases trapped in the magma deep inside the Earth.
Lava is in constant motion as expanding gas is released from within.
So when those gases get hot enough, they expand, and Expand and explode. See, a volcano is kind of like a bottle of soda. There's a lot of carbon dioxide in there. So if you put one bottle of soda on ice, and you put the other bottle under a heat source, which one do you think is going to fizz the most when we take off the cap? Look, I can't do everything for you.
Okay, let
Ice
me,
and heat.
let's see.
Okay, I'll do it. Fine. Hold.
This is an active lava field. This is an active lava field. A field of lava. And it is hot. The lava is flowing under the surface, right along here. Hot, hot, hot. Once in a while, the surface collapses and we can see in. It's called a skylight. The lava here is really moving. That's the cinder cone of a volcano. And down in the crater is a lava vent. It's letting lava that's under pressure vent to the surface. It's filling up. It's brand new land. The lava flows downhill in channels. The edges of the channels cool into a hard crust. Sometimes they form a lava tube like this one. The volcano ends up with a whole underground subway system of lava, building up new land and flowing sometimes all the way to the sea. Here it is. The lava is flowing into the sea. See? It's turning the ocean into steam. It's making brand new land. Talk about waterfront property.
The molten lava solidifies. New land is formed.
The wind carries seeds all over the volcanic landscape. If they happen to land in the right place, some of them start growing. Now, why do you think plants get started in these cracks? Well, that's where the water hangs out when it rains. So getting started on these smooth surfaces will be hard. The water just runs away. These plants are growing in soil that's beneath a layer of ash. But in a few years, with a few more rains, the plants will be getting their nutrients from the ash itself. The volcanic landscape will turn lush. This is a brand new lake, so there are new plants growing here. That brings in all kinds of new animals. Around here, nature has a way of regenerating itself.
Lava days at Magma Box with balloons for the kiddies and hot dogs. Beefy boy burgers, flame broiled hot. And as always, balloons for the kiddies and hot dogs from Mom and Dad. There's molten jelly, nothing hotter than balloons and hot dogs.
This is the cone of a volcano. Call it a cone because it's round and cone-shaped. When volcanoes stop erupting, a lot of times they form a little bowl in the middle. I say little. It's huge! It's 2 kilometers across. This is called a caldera. And under here is a chamber of magma. When the magma chamber fills up, the bottom of the caldera rises a little bit. When the magma chamber drains, the bottom goes down. Some volcanoes ooze. Other volcanoes explode. Please consider the following. Take a look at this. This is molten lead. It's liquid. It flows just like lava, just like magma. And no matter how long we let it sit there, it just sits there. It doesn't boil. It won't overheat and blow its top. But this is boiling water. It's only at 100 degrees Celsius. The lead's at 300 degrees Celsius. If we let it sit there long enough, eventually the pressure will build up inside here. Watch. It blew up. That's because the water turns to steam. Water vapor, a gas. It can expand. The lead's still just sitting there. Now this is what happens in volcanoes. Some oozing volcanoes form when a hot pocket of magma, a magma plume, finds its way to the surface through some cracks in the plate. Other volcanoes happen when one of the Earth's plates slides underneath another plate. If it's under the ocean, the plate gets soaked with water. Then later, when the Earth's heat warms up enough to form a volcano, it explodes! Kablam! Volcanoes come in different different shapes, depending on how they're formed. The shield volcano is formed by hot lava that flows down the sides quickly. The lava comes out hot and flows a long way before it hardens. That's why this volcano is sort of flat, like a shield. Next, is our cinder cone volcano. It erupts explosive, cinder, ash. So it ends up tall and sort of flat on top. And there's a third shape. It's like a combo of the other two. Call it stratocone. Sometimes it spews lava, and other times cinders, ash. Stratocone is tall with a symmetrical cone shape. So there you have it. These are your three flavors of volcanoes. There's a shield,
Yum,
cinder cone,
yum, yum.
and stratocone.
Yum, yum, yum. Could I have some, though? I mean, if there's any extra.
Vesuvius is a composite cone, or stratovolcano, built by many eruptions of ash, cinders, and lava. Vesuvius erupted violently in 1944. The whole world watched in awe as newsreels showed villages at the foot of the mountain crumbling before the advancing lava.
Honey? What does this remind you of?
Honey, you know what that reminds me of.
Come on, honey, I want to hear you say it. What does this remind you of?
Honey, it's embarrassing. Okay, if you insist. It reminds me of a stratocone volcano which builds up in the Earth's crust to make it big and strong.
Dad? May I please be excused from the table? Sure, son.
How hot is lava? I'll show you how hot. The lab says these rock samples all came from underneath the Earth's crust. And get this, they used to be hot goo, over 1,000 degrees centigrade hot.
Book 'em, Guano.
Can't exactly book them, sir. They're volcanic rock.
Volcanic rock.
And people say, why study volcanoes? Why bother? Why go to all this trouble? Well, I'll tell you why. Oh, yeah, they're cool. Oh, yeah, that's no problem. But I'll tell you what else. They're a window on the underworld. They're a window on what's inside the Earth, where all the land on Earth once came from. Look at it right now. Lava's flowing underground through a system of lava tubes, and it's coming out right here at the sea.
In Italy, brave volcanologists don revolutionary protective suits in hopes of getting a closer glimpse of the volcanic activity exploding forth from Mount Stromboli. Nakadake was formed about 5,000 or 6,000 years ago. Ever since then, it has been a very active volcano. The most recent large eruption occurred in 1990. If you count the smaller eruptions, the most recent one occurred in January 1995. About 50,000 people live on the caldera right now. So, at this museum, we are always using scientific methods to monitor the caldera activity, to study the effects of the volcano on the environment.
Okay, take a look at this.
This one's called Pahoy Hoy. The other one is Ah. And this ash and cinder goes by the street name the Aloha Bandit. No, Tephra. How did they get here? What kind of sicko would take molten rock from under the Earth's crust and spit it out like so much mouthwash? Could be that big volcano down the street. I've got it. The volcano.
This is a tree that used to be alive. All of these trees used to be alive. But they were killed just like that when a hot stone wind from Mount St. Helens blew through this valley. Now, a stone wind is a wind loaded with pumice, volcanic ash, exploding from the volcano at over 350 degrees Celsius. The stone wind instantly knocked trees down that were close to the explosion, and then it continued on for many kilometers, completely scorching thousands of standing trees along the way. Just like that.
Honey, we're out of soap again.
Don't get the lather, dear. Try some
It's lovely. Where's it from?
From under the Earth's crust, silly. Any other questions?
Just one. Scrub my back.
There are some volcanoes that may never erupt again. These are called extinct volcanoes, like Mount Kenya in Africa. It hasn't erupted in millions of years. The magma plume, where the lava used to come from, has cooled to a solid. Mount Kenya's extinct, so feel free to build a house on it. It'll probably be okay for centuries. A volcano that hasn't erupted in 200 years is called dormant, like Mount Rainier in Washington State. It's just sleeping. There's no magma flowing right now, but it could easily just snap out of its nap and you probably shouldn't build a house there. Then, of course, there's everyone's favorite, the active volcano. Stromboli off the coast of Italy. Active volcanoes are almost always shaking and rumbling and shooting off steam, or erupting. I probably don't have to tell you, you do not want to build a house right there. No, that's not good. Science! Well, that's our show. Thanks for watching. Do excuse me, I've got some airborne day-side particle levels to measure. See ya. Woo! Look at that pumice plain. Man, a day-side
Producer
dust.
Association with the National Science Foundation.
It's made out of brown haze. It's kooky. It's a volcano. Woo! Pumice plain. Pumice plain. It takes more time than that. I mean, some volcanoes sit there for hundreds of years, centuries, before they explode. Some just, a few hours. This one is taking longer than we expected, but that's one of the features of volcanoes, is the unpredictability of them. You see, that's why we study them. That's why we're doing a whole show on them, trying to figure out